Hello and welcome back to Gaffy's Grinds. My name is Mr. Gaffy, Leaving Cert chemistry teacher here, and I'm trying to take some concepts in Leaving Cert chemistry, break them down, make them easier to understand, and do some practice questions with you. This is video 4 in our module of organic chemistry. Just a reminder that if you have not watched videos 1, 2, and 3, the videos that came before this video is not going to make any sense. So you need to go back and watch them in order. Watch 1, 2, and 3 first. We're going to be looking today at something called isomers. A few tips, just a quick reminder that to get rid of your phone, put it on silent, put it in another room, somewhere where it won't distract you. Close any other tabs you have open on your computer. Again, we don't want any notifications to take away from your learning, because that's just going to stop you from learning to the best of your ability. And most important, the exercises and questions that I give you to do, you must do them, okay? Otherwise you are wasting your time here. So if you just sit and listen and wait for me to do all the questions, unfortunately, you guys are not going to learn as much. So it's really important that you do questions. Now, in our previous videos, we discussed the unique properties of carbon. Okay, so the unique properties of carbon and what gives rise to all the chemistry of carbon. So I want you to tell me now, or speak to the screen, tell me on 3, what is the chemistry of carbon compounds called? So on 3, 1, 2, 3. I'm hoping that you said the chemistry of carbon compounds is all called organic chemistry. So the study of carbon compounds is organic chemistry. And what is special about carbon is how many valence electrons and therefore how many bonds it can form. So you guys should know that now. So on 3, how many bonds can carbon form? 1, 2, 3. I hope that you said carbon can form 4 bonds. Okay, now because each carbon can form 4 bonds, it is sometimes possible to join the same number of atoms together containing carbon, but join them together in different ways. And let's take a look at an example of this. Okay, now we already saw how we can name some simple carbon compounds. Now I'm drawing a molecule here. It has 4 carbons in a chain. They are all singly bonded, and they are connected to hydrogens. Now, this is a substance made of hydrogen and carbon only. What is a substance made of hydrogen and carbon only called? On 3, 1, 2, 3. Good. I hope you said that it's called a hydrocarbon. Now, this is a molecule that has only got single bonds, carbon to carbon, single bonds. So it has the functional group of C, single bond C, like this. What homologous series does this belong to? So on 3, 1, 2, 3. I hope that you said this belongs to the alkanes. So this is an alkane molecule with 4 carbons. Okay, so the name, what we call the systematic name for this substance. You guys should be able to do that for me now. I'll give you a minute to pause the video and try and think about the name. Say it on 3. 1, 2, 3. Okay, 4 carbons. 1, 2, 3, 4. 4 carbons in chemistry is bute. So we give it the prefix bute, B-U-T. Now it's an alkane, so it belongs to the alkanes. That means the end of the name is ane. So the systematic name here is butane. Okay, now if I was to ask you to write out the molecular formula, the molecular formula just tells you how many and what types of atoms are there in this substance. So this is the type of formula that we would be most familiar with, the molecular formula. It tells us how many atoms are present and which types of atoms. So first of all, the first type of atoms I see are carbons. So carbon, I'm going to write the letter C to show that there are carbon. Now, how many carbons are there? There are 1, 2, 3, 4. 4 carbons. Now, the general formula for an alkane. So without count, I can work out the number of hydrogens without counting them, because I know the general formula for alkanes. This is an alkane. The general formula for the alkanes. You should know this on 3. What is it? I hope that you said it's CnH2n plus 2. Now, if n, where n is the number of carbons. So if n is 4, if there are 4 carbons, that means that there are 2 times 4, which is 8 plus 2 hydrogens. So H10. Now let's just check that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Correct. Okay. The same molecular formula. Now, The structural formula here, a structural formula, and we went through this in the last lesson, tells us a bit more about the substance. Structural formula tells us the order that these are in. I'll remind you how this works. It breaks it into these sections. So this here would be the first section. So this would be CH3. Then there's another section, CH2, like that. Can you finish that off for me? Let's pause the video, try and finish that off. What will the next two be? Okay, you should be playing now. If you've tried to tell me what the rest of that formula will be, speak it out now. So it's going to be CH3, CH2, this section here, CH2, CH3. Now, it should still be the same as this. There should still be, in total, 4 carbons and 10 hydrogens. 1, 2, 3, 4 carbons. 3 and 2 is 5, and 2 is 7, and 3 is 10 hydrogens. It's still the same amount of carbons and hydrogens. Okay, what I'm going to get you to do now is I'm going to get you to pause the video and I'm going to get you to take that down. Okay, you should be playing this video now if you have paused the video and you have taken that down. Now, what if we take another substance? And this is what the substance looks like. 1, 2, 3 carbons in a straight chain. But this molecule has another carbon which is not in a straight chain with the other 3 carbons. So it's what we call a branch. This is a branch because it branches off the side of the molecule. Now this carbon can hold 3 hydrogens. 1, 2, 3. This carbon can only hold 1 more because look, it's got 1 carbon bonded to 1 carbon here, 1 carbon here, and 1 carbon here. So it's already used 3 bonds, so it can fit 1 more. This carbon is an end carbon, which means it can hold 3 hydrogens like that. And this carbon, well, this has only got 1 bond at the moment, so it can hold 3 carbons. It's the same as an end carbon. Now, I'm going to skip the name of this one for a minute. So I'm going to write down name. No, I can just... Right. Okay, now, I'm going to skip the name for a second. We're not actually going to do the name in this. I'll tell you the name, sorry. So the molecular formula, I want you to figure out what is the molecular formula for me. So I'm going to get you to pause the video. And when I ask you to pause the video, I want you to draw this, okay? So beside where you've done this one already, draw this one like I have separated in a table. So pause the video and draw that. And then when you're finished, write down the molecular formula. So pause the video and do that now. Okay, you should only be playing the video if you've drawn this down and try to write the molecular formula. So I hope you got that there are 4 carbons, 1, 2, 3, 4. Now they're not all in a chain, but there's still 4 carbons. So C4. Now let's check. Well, technically, this is an alkane as well because it's all single bonds. What is another name for a molecule that has only single bonds in it? There's a word we use to describe that substance if it's all single bonds. What is that word? On 3. 1, 2, 3. I'm hoping you used the word saturated. So this molecule is saturated with hydrogens. There's nowhere where we could break a bond and stick on more hydrogens because all of the carbons are already full. They've all got 4 bonds already. Okay, now, so C4, and if you count the hydrogens, 1, 2, 3, 1, 2, 3, 1, 2, 3, 4. So just count them again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. H10. Well, wait a minute. That's the same as this. C4H10, C4H10. This is butane. This must be butane too, is it not? Well, the answer is it's not. Okay, and in the next lesson, we will learn how to name this structure here. Okay, we will learn how to name this structure. But for now, I'm going to tell you that it's called 2-methyl propane. Now, I don't normally like doing that, telling you just to take something down without explaining it. But because we're going to do it in the next lesson, I'm going to ask you just to do that for me for now, because it's not what's important here. What's important here is that we see that the molecular formula is the exact same here. The molecular formula is the exact same. Now, the structural formula here will be CH3, this section. Okay. We're then going to get this section here. C2H5, H4, sorry, C2H4, CH3. the last bit. Okay, CH3, C2H4. And you know what? I'm not going to do it like that. Sorry about that. I'm going to do CH, this bit, and then CH3. And then another CH3. Okay, now that's the structural formula. What's important here though is if we look at the molecular formula. The molecular formula here is the exact same, even though the displayed formula or the structural formula is different. So we've got the exact same atoms, the exact same amount of atoms, but their arrangement is different. Here they are in a line, in a straight line. Here they are not in a perfect straight line, there is a branch. It's technically the same sort of substance or the same sort of molecule, but the atoms are arranged slightly different. These two things are what we call structural isomers. Okay, so these are structural isomers. So if I was to explain using a sentence what a structural isomer is, we would say that they are molecules with the same, okay, well, what is the same about them? Well, they have the same molecular formula. Same molecular formula, but a different structural formula or a different displayed formula. In other words, the atoms are arranged differently, different structural formula. So these two things are isomers, not to be mixed up with isotopes. Isotopes are two atoms of the same element with different mass numbers because they have different amounts of neutrons. Not to be mixed up with that. These are molecules with the same molecular formula. That should say formula, sorry. Same molecular formula, but a different structural formula. Okay, so stick that in there, sorry. Formula. But a different structural formula. That is what isomers are. So these are examples of isomers. Okay, so I'm going to get you to pause the video at this point and just take down anything from this diagram that you don't have. Okay, it's time for you guys to do a little bit of practice now. Okay, so I am going to draw two molecules. Okay, so I'm going to call them A and I'm going to call them B. The first one looks like this. Okay. That's a lot of hydrogens to draw. It's a bit of a pain. I'm going to call this one A. I'm going to call this one B. Another one here. As you can see, it gets quite messy when you have to draw all them hydrogens. Apologies about that now. Right, I'm going to call this one B. So what I want you guys to do is I want you to pause the video and I want you to draw down these two molecules, A and B. Okay, good. You should only be now watching the video if you have paused the video and drawn down the molecules A and B. Now, what I would like you to do is I would like you to write down the molecular formula and the structural formula of each of these two compounds now. So underneath, you want to write down molecular formula, and structural formula. Okay, for each compound. Like that. You can do it in a table, something like that. Okay, so pause the video, do that now. Okay, now you should only be watching the video if you have paused the video and tried to write down the molecular formula and structural formula for each of these things. Okay, so the molecular formula for this one, for A, is, let's count the carbons. 1, 2, 3, 4, 5, 6. So C6. And I can count the hydrogens, or I can use the general formula for an alkane to work out the hydrogens. But let's just count them this time. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. And that does make, sorry, that should be H, C6, C6, H14. Okay. Now, I could, if I use the general formula, does that make sense? Well, if N is 6, then it should be 2N plus 6. So 2 times 6 is 12, plus 2 is 14. So that makes sense. That's correct. It is an alkane. The structural formula, let's see what I would write here. So this first section is a CH3. Second section, this here is a CH2. CH3, CH2, another CH2. I've then got a CH, CH3. And then finally, I've got this last CH3. All right, now this one, the structure, let's do the molecular formula. So just in number of the type of atoms and a number of each type. So I've got 1, 2, 3, 4, 5, 6 carbons. C6, and let's count the hydrogens. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. H14. Structural formula will be CH3 first of all, like this. CH3. I've got a CH then here. CH, and then I've got a CH3. CH3, and then I've got a CH again. And a CH3. Oh, yeah. And finally, I've got a CH3. Quite a messy structural formula. Okay, now I can see straight away that structural formulas are different, but I can see that the molecular formulas are the same. So the next question is, are these isomers or are they not isomers? So are they structural isomers? Yes or no? So underneath where you've written, where you've done this work, I want you to write these two. Sorry, I'm just going to rub this out. I'm going to write, start on a fresh page. I want you to tell me about whether they are structural isomers or not. So use the word structural isomers in your answer. Structural isomers. So I want you to tell me, write a sentence to say whether they are or they aren't structural isomers and explain your answer, please. Pause the video. Okay, so you should be playing this video if you've tried to write a sentence to explain if they are structural isomers or not. So it should read something like this. I'm hoping this is what you wrote. These two molecules are structural isomers. And why are they structural isomers? Because they have the same molecular formula but a different structural formula. Check your answer and make sure you said something like that. Okay, key thing is that they have the same molecular formula, different structural formula. These are the key things that you have to have in your answer. So we know that they are structural isomers because that is the case. The two molecules did have the same molecular formula, but different structural formulas. Okay, we've got another example, another practice question. So we've got three compounds, A, B, and C, with three separate compounds. The question I want you to answer is to figure out which of these compounds is not a structural isomer. Now, if you're confident that you know how to do this without any more help, I want you to go ahead and pause the video and try and answer the question. Okay. Now, I am going to help you a little bit. If you weren't able to pause the video already and go and do that question, I'm just going to give you a hint. The hint here is that hopefully by now you have figured out that if you want to figure out whether things are structural isomers, you first have to work out their formula, their molecular formula. So figure out how many carbons and how many hydrogens are in the formula. Okay, so now that I've told you that, pause the video and go and tell me which ones are structural isomers. Now, you should only be watching the video if you have tried to tell me which one is not a structural isomer. The next thing I want you to do is explain your answer. Explain your answer. So in a sentence, I want you to explain why you've chosen the one you did. Pause the video and explain your answer. Okay, you should be watching the video now if you have said which one is not an isomer and you have explained your answer. Okay, I said we need to work out the chemical or the molecular formula to figure out whether things are isomers or not. So let's work out the molecular formula for each one. For A, oh sorry, I should have made clear at the start as well. Each of these lines is connected to a hydrogen. I should have made that clear. Apologies. If you weren't able to figure out what was going on and you don't know what's connected to those lines, they are hydrogens. So again, sorry about that. Pause the video and try if you didn't understand that there was hydrogens. Try these two questions. Pause the video now. Okay, welcome back. And let's work out the molecular formula of these three compounds. Well, in this compound, I've got 1, 2, 3, 4, 5 carbons. So C5. At the end of each of these lines is a hydrogen. So let's count them. There's 1, 2, 3 hydrogens, 4, 5 hydrogens, 6, 7, 8, 9, 10, 11, 12. H12. C5H12. Okay, let's do it again for this one. How many carbons? 1, 2, 3, 4, 5 carbons. C5. This is looking good. This is looking, let's just count the carbons and make sure. 1, 2, 3, 1, 2, 3. That's 6. 7, 8, 9, 10, 11, 12. H12. Let's do this last one. 1, 2, 3, 4, 5, 6. C6. All right, that's not looking so good. Let's count the hydrogens. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. H14. Okay, so which of these compounds was not a structural isomer? I'm hoping that you went for C. If you did, well done. Explain your answer. Why is it not a structural isomer? I'm hoping that you wrote something about it not having the same molecular formula as the others. Okay, so it is not a structural isomer because it has a different molecular formula. So it is not a structural isomer of these two because it has a different molecular formula. Now, if I haven't already made it clear, I just want to make it clear that sometimes there can be more than one. So the examples we've looked at so far have only only two isomers. So these two are isomers, but it might not, other compounds might have more than two isomers. There might be 5, there might be 6. It's not always going to be just 2. So there is 2 in this case. Other molecules may have more. The bigger the molecule gets generally, the more isomers it would have. Okay, that is the end of this video, and we are going to come across isomers again in more detail later. This was an introduction. So I hope that you found the video useful, and I hope that you managed to answer the questions okay, and I'll see you in the next one.